watching this. Today I'm going to talk about how we graph lines that are a little bit off. So if they're missing the y-intercept, if they're missing an x, if they're missing a y variable. So things that look a little bit different than what we've seen. So let's start by reviewing slope-intercept form of a linear equation. That is y equals mx plus b. Also, please remember occasionally you're going to see it flipped where you'll see it as y equals b plus mx. The key is you recognize where that x is at to let you know where the slope's at. The constant will be the y-intercept. All right, so if you have this down, let's go ahead and move on to kind of the exceptions to that rule. So how do I graph a line if part of the equation is missing? Okay, so this is pretty text heavy today, so if you want to pause and write this down in your notes as we go, that'd be great. The concept is pretty straightforward, but there's a lot of words, so just bear with me. All right, what do I do if the x variable is missing? So if we have an equation that's like y equals b. Okay, in this case, you actually have a horizontal line. The slope is actually 0. So if you think about that, if we have y equals 0x plus b, 0 multiplied by anything just turns into 0. So this just goes away and we're left with y equals b. So it's going to be a horizontal line. If you're thinking about slope, dude, this would be a 0 fun, right? It's just going to go left to right. It's pretty boring. So in this case, what you want to do is place the y-intercept b on the axis. So you're just going to put it on the graph like you normally would. At which point, you don't really need to worry about putting any more points on the graph. You're just going to draw a horizontal line from the left to the right side of the graph that goes through the y-intercept. So we're going to draw, I have a little typo there. I'm just going to fix it right now. A horizontal line from the left to the right side that goes through the y-intercept. Okay, pretty straightforward. So it's going to be a horizontal line. Think horizon, think flat line as you look in the distance. All right, next one. What if the y variable is missing? This is the weirdest one out of all the ones I'm going to talk about today. So if the y variable is missing, you have something where you have x equals a constant, right? In this case, we have an x-intercept, as in we're going to put the first dot, the first point, on the x-axis as opposed to the y-axis. So we're going to place that x-intercept on the x-axis. This time, we're going to draw a vertical line, a line that goes up and down from the top to the bottom of the graph, and make sure it goes through that x-intercept. Okay, so it's going to be a vertical line. It's like, think vertical jump, think Michael Jordan jumping up and down, right? So it's going to be a line that goes up and down, right? So remember, slope, dude, in this case would be an undefined slope. Hence, it is undefined. There's no m. We can't define it. Okay. What if the x and y are present, but the b is gone? So we have something that looks like y equals mx. So we kind of talked about this a little bit last time. If we have this scenario where y equals mx, we're going to have we're still going to have a y-intercept. We just can't see it. So the y-intercept is there. You just can't see it. The equation, think of the equation as y equals mx plus 0, right? So that y-intercept is 0. So place the y-intercept at the origin. So remember, the origin is the point 0, 0. It's right where the x and y-axis crossed. And then we're going to use the slope to place 2 more points on the coordinate plane and then graph a line. So at this point, you're just going to treat it like any other line. This technically is in slope-intercept form, but a lot of students get confused when they don't see that constant next to it. So if that constant's not there, think of it as being a 0. Okay, let's look at a couple examples. So just so we don't get confused, I'm going to make the first one's going to be blue. I'll do a blue line. So in this case, y equals 4. Okay, I don't see an x. So this means I have a horizontal line. So I'm going to go ahead and place a dot at 4 on the graph, and I'm going to go ahead and insert, that did not work right. Go ahead and insert a line that goes all the way across the graph. So, my computer is not cooperating with me. Let's try this again. Insert a line that goes from the left side to the right side. So, I am having some technical difficulties here. There we go. Okay, so I'm going to insert a line that goes from the left to the right. There's my first one. All right, so let's do another one. Let's say we have the next one we'll make red. Is that what I wanted? Okay, the next one we'll make is, oh my goodness, this is not working with me today. Will be a red line. So y equals -7. So I'm going to go ahead and look down here. I'm going to put a dot right here. Then I'm going to insert my line. a horizontal line that goes all the way across the graph. Now, I know if you're using a Jamboard or another like free tool, sometimes they don't really cooperate with you when it comes to um, actually making that line go all the way across. So just do the best you can. All right, last one is y equals 1. Once again, we're just going to put a dot at the 1. Right, you notice there's no x. This is going to be another example of a horizontal line. So it's going to go to the one side of the graph to the other. Go ahead and make that green real quick so it matches what we're doing. Okay, so there we go. There's our line. All right, so this example, 3 examples of horizontal lines. The nice thing about these is they're pretty easy to put on the same coordinate plane. Okay, next graph we have, let's look at some vertical lines. So in this case, we don't have a y variable, and we're going to go up and down. All right, so we'll make the first one blue. We'll make the second one green. We'll make the last one red. All right, so x equals -5. So remember, this time we're not looking at the y-axis. We're not looking at the y. We're looking at the x. So if I look at this, here's where x is 0, -1, -2, -3, -4, -5. I'm going to put a dot there. Now, just like with when we're graphing a horizontal line, we want the line we actually graph to go the opposite direction of the axis we put that point on. So in this case, we're going to go up and down. So I'm going to go up here at the top at -5. I'm just going to draw a line that goes from the top of the coordinate plane to the bottom. Always has to move a little bit when I move the mouse because, it can't be easy. All right, so there's our first example of a horizontal line. Okay, now let's insert the next one. So this time, x equals 8. So the origin's here. This is where x equals 0. I'm going to count over 1, 2, 3, 4, 5, 6, 7, 8. You see the 8 there. Not every coordinate plane is going to be marked. Okay, so I'm going to put my point there. Then I'm going to go ahead and insert a line that goes from the top of the graph to the bottom of the graph. Right, another horizontal line. I got lucky there when I released the pin. Very kind to me. That's always good. All right, the last one we're going to do is x equals 0. This one's kind of weird because it's just going to overlap the y-axis. Oh my goodness, I didn't want to do that. There we go. So x equals 0, we'll put that right here. Then I'm going to go ahead and insert a line that goes from the top to the bottom. In this case, it's going to, like I said, it's going to look a little funny because it's just going to overlap that y-axis. So there we go. All right, so those 3 examples of vertical lines. All right, so if you don't see the y, right, it will be a vertical line. It's going to go up and down. Okay, now let's look at the scenario where we actually have something in slope-intercept form, but we're missing the b variable. We're missing the b or the y-intercept. So remember, in this case, we want to think of it as y equals -2x plus 0. So we're just going to put the first point at the origin. And then we're going to graph it like we would normally. We're going to use the slope to put more points on the graph. We want at least 3 total points, the more the merrier. So I'm going to go down, in this case, it's going to go down 2, right 1. Down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Now remember, if we have a slope that's like, that is an integer, like both of the examples, you could think of it as -2 over 1, which means we're going down 2 and then right 1. All right, now I'm going to go ahead and insert a line that goes from one side of the graph to the other. There we are. It's shifted a little bit on me, but you guys get the idea. All right, so make it the same color and move on with our day. All right, now let's do one last example, and you guys have a pretty good idea how graphing these kind of oddball lines work. So I'm not going to go ahead and add the 0 for this one. We know how it works. I want that to be, oh, ooh, that got confusing. Hold on a second. I accidentally made that the wrong color. There we go. Okay, so there we go. So I'll make this one red. So I'm going to put a dot here. It's going to have the same start value or y-intercept. This time my slope is 4, so I can think of 4 as going up 4, right 1. Right, you can turn that integer into a fraction by just simply putting a 1 in it. So I'm going to go up 1, 2, 3, 4, right 1. Up 4, right 1. Okay, put a couple points on the other side just for good measure. And then I'm going to go ahead and graph my line that goes from one side to the other. Okay, so, oh, I made a mistake. It does happen. Look at my mistake down here at the bottom. So I went over the wrong direction. I went over too far. That's why my line's going to line up. So that mistake is fixed. Now I can graph that line. Yeah, I make plenty of mistakes, trust me. That's practice makes better. It will never quite make perfect. You're always going to make mistakes. Okay, there we go. Okay, so just a quick review. If there's no x variable, you will have a horizontal line that goes from the left to right. Just place that on the graph to make a horizontal line. If you don't have a y, you're going to have a vertical line. This is the weird one. This is one where you actually have to put the dot on the x-axis instead of the y. Once you place on the x, it will make a vertical line. And then finally, we have this scenario where we don't have a y-intercept. Remember, if you don't have a y-intercept, but you do have a slope, the y-intercept is indeed 0. All right, thanks for watching. Have a good one.